This is part 7 of the series Three-Dimensional Solids, and in this part we're going to work several examples of finding the volumes of three-dimensional solids of various types. Let's start out with the first one here. We have a right triangular prism. Now this is a right prism, and as it appears, the base is actually a right triangle. So we're going to find the volume of this guy and start out with the formula. So we know that volume equals area of the base times height. That is the volume in general of a prism. Now this prism has a height of 7 centimeters. That makes this area of the base times 7. So now we need to calculate the area of the base. So let's go up here. Big V equals, the area of the base is just going to be the area of a triangle. So that's 1/2 base times height. Now this is not the height of the prism, this is the height of this triangle here. Well, we're going to need this side and we're going to need this side. Let's call this the height. So this side is going to be 15, so we can make that 15. And we need this base here. So since this is a right triangle, and this piece is 15, and that's 17, we know that this must be an 8, 15, 17 Pythagorean triple. So we know that this is 8. Now if you couldn't see that, just use Pythagorean theorem, and you could call this side x. Over here, you could say that this was x here. And so you know that x squared plus 15 squared equals 17 squared. X squared equals 17 squared minus 15 squared. And then x equals the square root of 17 squared minus 15 squared. And that's going to come out to 8. Alright, so we know that this base length is 8. And there is our formula for the area of the base. So let's go ahead and calculate what that guide is. That's going to be 60. So we know that our volume then becomes 60 times 7, which is 420. 6 times 7 is 42, times 10 is 420. So there's our base of the prism. Fairly straightforward example. Alright, let's move on and work another example. In this example, we have another right prism. In this case, the base is a trapezoid, so this is a right trapezoidal prism. And so let's begin. As usual, we'll write down the formula for volume. So volume is area of the base times height. And the height of this prism is 5. So this is going to be area of the base times 5. Now we're looking for area of the base. So let's go up here. Area of the base is the area of a trapezoid. And if you recall the area of a trapezoid, it is 1/2 height times base 1 plus base 2. Hopefully you remembered that. In this case, we know that the height of this trapezoid is 7, and this distance from here to here is going to be 12, and this distance is 9. So we'll call this base 1, and we'll call this base 2. 1/2 the height, which is 7, times 9 plus 12. That is base 1, which is 9, plus base 2, which is 12. So this becomes 1/2 7 times 21, which is 73.5. Then that makes the volume 73.5 times 5, which is 367.5. All right, another straightforward example. We just had to know the area of a trapezoid formula. All right, let's move on to another example. In this problem, we're looking for the volume of a right cylinder. So as usual, let's begin by writing down the formula for volume. So volume is area of the base times height. In this case, the area of the base is simply a circle. So we can just put this in line. That's going to be pi r, which is 7. So let's just put the formula down. Pi r squared h, and then that becomes pi 7 squared times h, which is 5. And that's going to equal 175 pi, or approximately 549.8. So there was a pretty easy example. Again, notice the formula. Volume is just area of the base times height. That's going to be the same for all prisms and cylinders. Let's move on to another example. In this example, we're asked to find the volume of an oblique cylinder. Now, based on Cavalieri's principle, we know that the volume of an oblique solid is the same as a right solid with the same dimensions, the same area of the base and the same height. So we can just do this as we normally would, as though this was a right cylinder. Therefore, the volume is going to be area of the base times height. In this case, we have, again, pi r squared times height, which is going to be pi 6 squared. Our radius is 6, and our height is 14. We put that in our calculator, and we get 504 pi, which is approximately 1583.4. So, another basic example. Let's move on to another one. In this example, we enter the lovely world of pyramids. This is going to require a little bit extra work, but not a whole lot. And we have this right square pyramid. So it tells us that this is a square base with 16 units on a side. In order to be able to find the volume of this, we need to know the height of this pyramid. So what I'm going to do is I'm going to take advantage of the fact that this is square, and I'm going to draw in my own right triangle inside here that I'm going to solve. So let's go ahead and draw this down approximately at the center place here, and then draw something over here. We'll just make believe that that's a nice right triangle inside there. And what we want to do then is we're going to want to find the dimensions of this shape. So since I know that this piece is 16, this is going to be half of that because this center is bisecting that side. So this value is going to be an 8. And that turns out to be an 8, 15, 17 Pythagorean triple. Again, if you're confused by that, just do the Pythagorean theorem. let's call this h. And so you know that 17 squared equals 8 squared plus x squared, and then 17 squared minus 8 squared equals x squared. Take the square root of both sides, and the square root of 17 squared minus 8 squared equals x. And this is going to come out to exactly 15. So I know that h is equal to 15. And so our volume now becomes 1/3 area of the base times height. And so this is 1/3. The area of our base is simply going to be 16 times 16. So this is going to be 16 squared. That's the area of our base, because it's a square base, times our height, which is 15. Alright, let's go ahead and plug this into our calculator. And this becomes 1280 exactly. Alright, not too terribly bad. The problem was set up nicely because it gave us even values that we could generate a nice Pythagorean triple here. Alright, let's move on to another example. In this example we have a simple right circular cone, and so let's begin with our volume calculation. Volume equals 1/3 area of the base times height. And since this is a cone, it has a circular base, so that's 1/3 pi r squared h, which is going to be pi 6 squared, because our radius is 6, times the height, which is 12. Alright, now we just plug that into our calculator, and that gives us 144 pi, which is approximately equal to 452.4. We're approaching the end of this part, and I still have a couple of examples left to work, so I'll pick those up in the beginning of the next part. So I will talk to you in the next video.